G'day Bifrosters. So let's keep going with the sorting. Now here is our setup from before, and something you should notice whenever you're building something for yourself or for distribution or for to put up on the forums or just for a bit of fun, keep an eye out for things that are repeated. So we have lots of repeats here, and this worked well for what we were doing. We're sorting by proximity or X, Y, and Z or whatever, but we have a lot more things to add in to make this more like the Houdini node. So I think before we get started on adding the new sorts, what we should do is make a system inside of here that tidies all of this up and allows us to have a nice pull down menu. And that system is called a custom enum. Let me show you one. So you live in the value node, and you come in here, you go to other, and you change it to, well, you see here are all the ones that I've made earlier. So for example, if we have a look at the time enum, which I used in my time warp, and you can see that it's got a pull down menu that's custom. Great, totally great. So we need to make one of those. How on earth do you make one of those? Well, you go to your compounds and you need to make a new JSON file. Now here's the time enum. This is what it looks like over here, and if we just go back here and undo the delete, we can do some correlation here. So you can see first off you've got your header, metadata, the name, meta value, they're all pretty default. Namespaces, again default, and then in types is where everything happens. Starts off with enum name. This is the group it gets put in. So if you remember when we went to look for it, we went to other and enum. And you can see they're all broken up. These are the simulation ones, Maxime stuff, collections, things like that. So these are basically the groups you put it into. If we come back here, you can see Valhalla and then Valhalla here as well. Then this is the members of the enum. So this is like what you want. You pull down, and the first one is seconds. We can have a look at that. First one is seconds, then ticks, then frame, and frame. Finally, frame length. And they're all given a number as a string. So what we'll do is we'll save as, and we'll go to all files, and we'll call this sortverts.enum. So we're just doing a save as and renaming it, and we're going to build our menu of what we want to do in here. Now here's what the Houdini node does, just written out as text, and we're essentially just going to use the heading. So the first one's going to be no change, and that's enum value 0. That's great. And the second one we want is X. The third one we want is Y, not T. The fourth one, you should be getting the idea. We want is Z. I'm going to put another one in, and to put another one in here, you need to copy this entire thing, making sure all your brackets and commas are in the right place, and then paste it. And let's call this one proximity, and we'll change the enum value to 4. So we'll save that, and now what we have to do to get Bifrost to pick that one up, because this isn't going to be there just yet. If we go here, you'd expect to see a sort verts. There's a sort, which is one I started making earlier. You can have a look at it if you like. It does a lot of the same things, but it's not the one we just made. So what we need to do is restart Maya, and then it'll load up that again. Now we're going to put more into this menu, but I thought just to get us going, we'll do the ones that we've already got here. So we've got X, Y, and Z and proximity, and I've put X, Y, and Z and proximity. So first part of this is I'm going to be showing you how to change this into a pull down menu. So I'm going to pause while I restart Maya. Now it's not showing up because I made a mistake. I need to put a comma in there. It's a small thing, but you need to be very careful with enums. I've been caught out by that before. You do it, you save it, everything's fine, and then you try and find it again, it doesn't work. The worst that can happen is you put a string in there and it stops Bifrost from loading. So I will be right back again. Drop down a value node. This time's the charm. Sort points. Now, why is it called sort points when this is called sort points? Because the name is what it finds the enums by. And so this was still set to time when I last tried to save it. I've changed it now, and now it's working. So we can check that by going no change, X, Y, Z, and proximity. No change, X, Y, Z, and proximity. We're away. So let me show you how one of these works. What you actually need to do is have two of them. Well, you're going to end up having a lot of them. So first things first, let's put this in its own compound just to keep things tidy. And then I'll show you how everything works. So I'll put that in there, and I'm going to call that enums for now. And we need to have some inputs and outputs here. Well, yeah, we're going to need outputs later, but we'll need inputs for now. So very first thing that has to come in is this itself, the menu itself. So something needs to get plugged into that, and what that has to do is if we come up to our inputs, and I'm just going to real quick, I'm going to delete all of these except for the two things we need, the point and the remapped array, and I'm going to put this in here and just call it method. So right now all this is doing is I've connected the input of my enum to the input of my compound, and then connected it to the input of this node, sort vectors example, on the Bifrost, in the Bifrost graph. And now you can see the menu has been promoted up, and there it is. Now, the way this works is you need to set up a bunch of cases. So what you're saying is that if this is equal to no change, then do something. And then you can set this to X, and you're going to need another equal. So if what's coming in here is equal to, and unfortunately you have to do it for every single menu item. So let's get on with doing that. It won't take too long once we get rolling. Only one of those, and then that just changes to Y. Another one, and that just changes to Z. And one more, and that's going to change to proximity. So we've got a whole bunch of, we've changed all of these to true and false. So does it equal no change? True or false? Does it equal X? True or false? So right now we need to set up our if statements just like we had before. And what we're going to do is basically recreate this inside of here. So we need our remap array. And the first one is really, really easy. So if that is no change, then that's what goes out. And then this goes to the output here. And we did this pretty much exactly the same thing in part one, except we did it like with checkboxes, which is what if statements give you by default. So we'll do another one. So this one is if it equals X. So that condition comes in there when it wants to hook up. So what are we going to do if it equals X? And now we start to need to bring in all of our logic into here. So let's get on with that. Before we do though, I'm going to need to make this node, so the vector to scalar, vector 3 to scalar. I'm going to do all of this stuff up here and pipe it down. So we only need to do that once, basically. And this is where we can start to do some fairly interesting stuff. Because, like I said before, we're looking at all of these repetitions, and remember what we're doing here is we're sorting the array, or we're turning the array into a float somehow. In this case, we're sorting it by its x, and then we're taking the original array into the for loop, finding this in the array, and then outputting it that way. So we're basically reordering our indexes. Now, what we want to aim for is basically just one of those. So let's take this in there. We'll take both of them in. And this is just a little bit of a entry into logic here. I'm going to disconnect this for now, and I'm actually going to just pop these guys right down the bottom, and we'll get back to them later. So this is the no change. This is what you do when it's no change. So what I'm going to try and do is I'm going to try and change what comes out of this based on this menu. So if it's x, well, then we want x to come out, and then that goes into the sorted array, sort array. And we are going to need the original array coming. We do have the original array coming in. Sorry, my bad. So we'll need the array before it was sorted, which is here, and also here. So this is where all of our statements are going to start to work. And then we need the array that we're remapping, goes in there, and that's what goes into the output. So if I get this right, and there's going to be some extra weirdness coming along later, and we'll be doing extra things, but for now, basically, what I'm trying to do is just swap this input based on this menu. So let's try y. So we need another if statement. We need to bring the y down to here, and this is if our input array, or our input enum, is equal to y, then this is true. So we need y coming in here, and we plug this into the false case. If it's set to x, then x is true, and that one goes through. If it's set to y, then x is false, and this one comes through. And we're going to rebuild that chain. But what we're doing it now is we're doing it one level back. We're doing it with the original array, rather than, if you look up here, rather than this is the chain I'm talking about. So rather than just checkboxes for what we're doing to change our output from all of our calculations, we're changing our input into our calculations here and just doing it once. Because if you choose X, then you're never going to get anything else in that menu. It's not going to try and do anything twice. That's a very different lesson, and it's a lot more complicated. So again, we'll do it with Z. Throw down an if, plug the Z in, plug the Z in here. This goes to false, and then again, this is all going to follow through. So if X is false and Y is false, then Z is what is tested next. And then the last one we need to do is proximity, and we're just doing exactly the same thing. So we go if, this goes in here, move all this along to get a nice looking chain, and maybe actually if we grab it, so at this point, what goes into here? What's our true case? Because it's not just the X, Y, and Z. This is where we need to bring in another one, or another bit of logic. We've already got that logic because we built it for the first one, and that's this bit down here. So we're going to need another input into our choice array, which is the point that we're getting the proximity to. So point prox to. Clumsy, I know, but it's late and I'm tired, and you're just going to have to deal with it, really. And then all we're going to need to do here is recreate this logic for our if statements inside. So we'll copy that, go into here, we'll paste this one down, and we'll hook up everything we need to hook up. So the remapped array, that's our remapped array there, and the point is the point prox to there. So once more, we're subtracting the point from everything in that array. We're getting its length, and that length is what goes and gets sorted here. So I don't need the sort array, I've already got that. Then the length output goes into here. So let's test that now. So now we've pretty much reduced all of this to one node. Sorry, I'm going to do that. Now we need to see if our fancy new menu works. So I'll pop that into there. Before we do anything, no, that's because this is set to X. What happens if I hit no change? Yeah, that does break. Okay, that breaks. We'll need to go fix that, but we'll check out the ones that we've got. So X, there's the X-axis there, that's right. The Y, yep, that's doing it. The Z, and we'll have to turn it around a bit. That looks like it's doing it to me. And then proximity to point, not showing where the point is, but that looks like it's sorting by the proximity to something. So that's pretty good. We've reduced all of this down to one compound, and more importantly, we've only got one sort array and one for each at the moment. So we have to find a way to get around this sort array, and I think what we're going to need to do there for our for our no change, which is here and here, is this if statement. I think we'll take this out of this loop, and we're going to go and put this after the for each. So because no change literally means no change, I don't want anything to change, I just want it to pass straight through. There are several circumstances where I could see that working. I'm going to make this happen first. So when I say first, it's going to be the last thing that happens before the output. It's going to check to see if you want to go for no change or if you want to go for something else. So if this is false, we want the result of this for each. But if it's true, we just want our original array. So this means if I've got this set to no change, it's going to ignore what comes out of here and just pump out the original array. So we'll pop that into there. We'll go up a level, and we'll give that a check. So proximity, Y, no change. Yep, that worked. Now it's not reporting an error. So you can put a point into there if you've got a point. We did have one, but I think I got rid of it. I did. That input is confusing everybody, including myself. But you can either put in a vector that you like, or you can feed a point into there, and it'll do the proximity of the point, but only if this method is set to proximity, like this. And the reason it's actually doing something is because we have numbers in there. Cool. So that's got everything into a nice little menu that's shown you how to make the menu. For the rest of this one, we're going to go through and add some of the Houdini functionality. And here's the Houdini functionality. We've got no change. Well, we've done that. Let's just make a little bit of organizing. We'll just make a little separator there. So we've done no change, and we've done by X, Y, and Z. So we'll pop that up there. And we've done proximity to point. Now, some of these we're not going to try and do, because, for example, something like by expression, as far as I know, you can't put an expression in Bifrost yet, so there's no way we're going to be able to do that, so we'll get rid of that one. By attribute, I'm not sure of. We're going to have to explore that together. By vertex order, and we'll make another little separator down here for the possibles, like that. By vertex order, this is working with Houdini's primitives. Now we can do something similar in Bifrost. We can sort the points by the order of the object that we're getting the points from, or by an object that you put in. But the problem is, if you have a cube with 8 points, and you have 75 points in your array that you want to map, that you want to order by the vertices of that cube, that's not going to work very well or very easily. It is possible, but it's kind of outside the scope of this at the moment. There might be a part 3 where I handle the harder ones, but I've got a feeling this one's going to take 45 minutes to tell you all about anyway. What are we left with? Well, we are left with reverse, random, shift, a long vector, and spatial locality. Reverse and random are pretty easy. Shift isn't too bad. A long vector I haven't tried, and spatial locality I haven't tried either, but that is pretty much a sort by proximity to closest point, I think. So it's a matter of going through, finding what 2 points are closest, and then going out from there. So this one we may not do, but these 4 we definitely will. So let's get a reverse going on. So what does it say in Houdini? It says reverses the current ordering. So that means it's got to kind of sit outside of this. And the easiest way to do that is to reverse the array coming out, which is this one. But it needs to be an option. So how do we get around that? Well, we just put an if statement out here. If statement out here. That's the true case sorry, this will be the false case if we don't want to reverse it. And this is the easiest one of them all, and that's why I'm doing it first. Reverse array, there's already a node to do it. Pop that into the true case. And then these guys, that one is our logic, and I believe that one's our display. So let's try that if I turn on the reverse condition. Yep. You can see the colors. 0 is red, and the end of the line is blue. So you can see that's reversing perfectly. What we will do is we will have an input to this, or we'll set this up. At the moment, it was supposed to be just one node, so we can still set this up as just one node by simply grabbing these guys, grouping them. Then we go in here, give it a bit of a layout for niceness, and all we have to do is put out our reverse, rename it, reverse current order will do. That's nice, and then rename this sorting method. So you came for the sort, but you're getting the bonus organization and logic. So there you go, 2 for the price of 1. Thank you for shopping at Valmart. I hope you have a nice day. But now you've got this compound, which is still nicely called compound, but I've got my reverse current working just as a click box, and then I've got the menu, X, Y, etc. So we didn't actually need to add to this menu for reverse, because reverse sits outside of that menu system, because it depends on how it's sorted as to how it's reversed it. So a quick example of that, grab this one, let's sort by proximity, there's the proximity, and now let's turn on a reverse, and there it is. So you can sort everything by the proximity to a point and then reverse the order. Perfect. Go back to our list of things. So reverse, that's done. We can put that in a different place and pretend it's ticked off the list and everybody's happy. Random, now this is going to go into the menu. We're going to do this the same way, and we're going to do this inside the sort vectors. And one more inside the choice. So we've ended up with probably one more level than we need. So if we're going to do it inside of here, we need to put it into the menu. So let's go ahead and add that now. So we go back to our enum, our sort verts, we copy all of that. Make sure you have a comma. And we'll just change this to random. Change that to 5. Save. Save, and I will see you when I get back. Okay, so if we just now look at our menu, we have a new one, random. Now this isn't hooked up yet, so if we come in here, just lay that out so that it's not so difficult to find all the time. To make random work, all we need to do, I'll bring this up here so it's a bit more out of the way. All we need to do is copy these two, change this one to random, put in a new if statement for our random, and then we can start doing the logic for the random array. Now, here's where we run into a little bit of an issue. in that this sort, which is helping us out for 4 of our things, at least half of what we're trying to do is running through this sort, which is sorting them from smallest to largest. Of course, if we want a random, that's not going to work, because if we do anything random, we're going to have to sort it again. And that's way down here, and that's up there. So how do you get this working? So this is going to be another example of, we put the if statements on. Oh, come on. Please. We put the if statement somewhere else. And where we're going to put the if statement in this case is between the sort and the for each. Okay, that took a little bit of sorting out, but we got there in the end. So here's what makes it work. Right now this is saying that this is the random choice. If random is on, take your sorted array. Sorry, my bad. Let's start that again. If random is on, we're going to take, and it's very important you remember which one you take. We're going to take one of these outputs. It doesn't matter which one you take as long as you choose it for the next thing as well. We're going to take one of these outputs. I'm using the Y in this case. We're going to shuffle it, and we're going to put it into this if statement that says if you have chosen random. If you haven't, we're going to take this one, and this gets put up into sorted, like so. Okay, the way that this works is the same thing that you choose to shuffle needs to go into the very last, when you take it out it doesn't work, needs to go into the very bottom, the false case here. Because what's happening is that all of these are false when this is true. Because that's the way enums work. If you have random, you can only select one thing at a time. You can't have anything else as well as random. So this whole chain is false if this is true. Which means that this thing, the shuffle array here, needs to come up through this chain and go out into the original, which is where inside the loop it gets compared to pull the indexes out to re-sort our array. So we somehow need to get that out, and the way to get that out is to run it up the false chain. So if all of this is false, then what it's going to be passing out here, as well as here, but this doesn't matter because this is true, what it's going to be passing out along this branch is the same thing you put into the shuffle array. And now, if we come back out here, we have no change, X, Y, Z, proximity, and random. Now I can presumably change that random by changing the seed I've given it, and I haven't promoted the seed up yet, but I will. So let's go in here, we'll grab the seed. It's at 0 at the moment, let's go to 25. That changes. 5,846, that changes too. So that's now working. Took me a little while to work out the logic, but once I worked out that it was trying to get the original, there was no array, there was 0 array coming through here. So there was no data coming through here to compare our random points to get the indexes to resort this array with. So everything was breaking. Once I worked that out and put this into the false chain, and up it went. That way, when this was true and all of this was false, this bit of data here was getting the right thing and everybody was happy. What's next? Shift. What this needs to do is it basically needs to offset the indexes of the array and then wrap it around. So there's a little bit of like logic going on here by itself. Oh, I forgot. We can take something else off our list. Nice. If you're the kind of person that likes crossing things off lists, well, there you go. We've crossed another one off the list. So this one needs a little bit of logic of its own, where it shifts the entire indices of the array. And if you remember here, reverse is the current ordering. This is another one we need to do outside of here, so it may not actually need the enum at all. Current element numbers. I believe that this one is done to the array after you've done all your ordering. So out here is where we're doing our reverse array, if it's reversed. I think what we can do is we can set up our shuffle in its own if statement out here. So we'll go ahead and do that. First thing I'll do is another if statement. We will run this out to here. And this will turn up as another checkbox here. And we can reorder this as we like. And I'll show you how to make that look better a bit later once we redo all the renaming and tidying up. I always do that at the end to get so I've got all my elements to shuffle if I need to. And what shift is going to need is it's going to need a number to add to the array. So we already know that if it's false, then we can just do that. So now we basically just need to build the true case. So here's one I prepared earlier. This, don't worry, I'll walk you through it. We'll do it together. But this will do the shift, as we said. So first thing we need is a get array indices. Yes, I'm leaving it there because I've forgotten how to do it. And we get that from the array. Second thing we do is we need the size of that array. And then we need to decrement that by 1, which will give us the index of the last value of the array. So we just decrement by 1. There we go. So here's where we need a couple of things. So what we need to do is we need to, thank you Bifrost. We need to take the array indices and we're going to add a number to all of them. And that number is what we're going to be shifting it by. So let's run this out as an input. Rename that to shift by. So right now it's 0. But you imagine it's adding 2. So it's going through all the array indices and adding 2 to them. Right there. And now we need to see if this number, so this has shifted everything forward by 2. If this number is greater than the last last index in the array, we need to do some stuff to it. So we need a greater node. So, oh my goodness, that's so annoying. Need a greater node. So if that is greater than the last value of the array, then what are we going to do? Well, we're going to subtract as you can see in my notes up here, we're going to subtract whatever that number was, and from that we're going to take away this, which is the length of the array. Need an if statement for our greater. And that's what you do if it's greater. So say for example it's 2 and there's 20 in the array. We get to the end of the array. This number is 22. This number is definitely greater than the last index in the array. We'll need to bring that through as our false case. So that just means if it's not greater than, then just leave it as it is. So we've got 22. That is definitely greater than the last value in our array. So we take 22 and we take the last value in our array off of it, which in this case would be 19. Or 20 rather. No, 19. So that would now become 3. And you can see that's how it shifts it back. So 20 becomes 0, 21 becomes 1, 22 becomes 3, 23 becomes 4, and it all cycles around. Possibly not the most elegant way to do it, but not terrible. And then the last thing we need to do is get from array. So instead of, this is just what we're doing in our for loop, but instead of doing it as a for loop, we're going to do it implicitly with the arrays that we get. We take this guy here, which is our array coming through. Oops, I did that in the wrong place, didn't I? That's alright, we need to make a compound out of it anyway, so we will grab all of that and we'll group it. We'll call it the shift compound. Go back in here, lay it out. We just need to hook this back up again. So get from array is that array, and then that goes to the output. So this is where we've shuffled all of our things. Either if they're greater, we do a subtraction. If they're not, we just leave them as they are. So this is where we've done all of our shuffling, and then we're outputting the result of that. And what needs to happen here is this array needs to go in there, and this needs to go into the true. So this is basically telling us, just hover over that, input shift. So this is like, do you want to shift? And then if that's true, you do want to shift, it runs everything through this compound. If it doesn't, it just runs it straight out. And if we want to shift by 2, you can see it shift by 2. Otherwise, not. You have to rely on me because you can see the colors change. Because we don't have numeric values working just yet, but you can see the colors shifting around. Might help if we got a better. Let's sort this by Y, so we can get a better view. We'll just go to some side view there, and then we'll shift it. You can see how, if I turn that off, if I turn it on, shift by 0 will give us the same amount. Shift by 1, and the first becomes, so the red, okay, let's go back a bit. Shift by 0, nothing happens. Now, the red is the first element in the point array, and the blue is the last. So, if I shift this by 1, then the last becomes the first. And you can see that, because it's gone blue, and the next one has gone red. Cool. And I think that's where we're going to leave lesson 2. Because we're now at the end of what I've planned and what I know, and we're going to have to work out how to do the rest. So we've got one more that we can shift into our done list. There will definitely be a part 3, because this is getting very long and it's getting very late. And in part 3 we will do a long vector and spatial locality. These guys I'm going to have to look into. So they're possible, but we don't know if we're going to do them yet. So let's just save this. I'll make this available. It's still in an unfinished state, but I'll let you play with it to see what's going on. The only other thing I might do is I might just move that up by 1. Move port up. Lovely. And I believe I can still reverse the current. I certainly can. You can see how it changes the strand that it's automatically building for us as well. Alright, so that's everything for today. We added quite a lot today. We changed the entire way things are done and made ourselves have to click through a lot more things to edit it, but that's alright. Once it's done, it's just one compound. I'm not going to do the breakdown because pretty much we're not finished. I'll do a big breakdown when we're finished. And yeah, I hope that helped, and have a good night.